Front center?
Jay's gone.
Yeah, I saw that. Okay. So,
This is terrible.
it is a learning curve. I'll have to warn you with that. So, yeah. Okay, so chapter 4, we have been working with quadratics. So we've graphed quadratics in general, standard, and vertex form, and we've been trying to solve quadratics. So we've solved quadratics by factoring. We have what's called the AC method. We were square rooting both sides. Here is another way of solving a quadratic. If those aren't enough ways to solve one, here is another one. Okay? Right? So there's multiple ways of graphing. There should be multiple ways of solving something. So this one is by far the most complicated one. Not very user-friendly. Okay? So, I'll give you the steps on how to do this, so hopefully we won't cry today. So, does anybody remember what a perfect square trinomial is? We learned this when we started factoring.
Square.
What is a perfect square?
A1.
What? Oh, 81. Sorry, here you go. Yeah, because it's 9 squared. We could have what other kind of perfect square? Or what's another example? 16, because it's 4 squared. Right? So, we should be able to recognize all these perfect square numbers. What does trinomial mean? Okay. 3 terms. What are you doing? Okay. So 3 terms would be like x squared plus x plus 1. That's a trinomial? Mm-hmm. Okay. So perfect square trinomials were the form like a squared plus 2ab plus b squared. So we should be able to recognize that the first term is a perfect square, the last term is a perfect square. So whenever you have that, it will factor to be a plus b to the second power. Right, there was that shortcut to factoring. You could have done AC method to get there, but this was the shortcut. We also had what it was subtracting. Same thing, the first and last were both perfect squares. We should be able to recognize perfect squares, and then it factors to be a minus b squared. Okay, most of us probably did AC method or just factored it. Didn't recognize perfect squares. Now you kind of have to. You're forced to. Okay? So, first example is going to lead us into what we're going to call completing the square. So, this example on the left side, what should we notice? Okay, we have a trinomial because that's 3 terms. Beautiful. What else do we notice about the left side? Okay, 100 is a perfect square, x squared is a perfect square, even 81 is a perfect square, but I'm not concerned about him because it's not a part of the trinomial. Okay, but this x squared plus 20x plus 100 should factor to be some quantity squared. So does anybody know what's going to go inside this parenthesis? X plus 10. How did you know that, or did you just guess?
No, I know. Basic math.
Yeah, so first term you just square root it. Square root of x squared is x. The square root of 100 is 10. That's where we got those lovely numbers. Okay?
So you just kind of think about this.
Yeah, if you distribute this out, x plus 10 times x plus 10, you get back that 20. Okay, so now it's in like standard form or whatever you want to call it. So since we factor the left side, I can get rid of the squared and try and solve for x. So that's my goal, is trying to get x by itself. Okay, so square root both sides. X plus 10 equals what? What are we going to see with that? What are we missing?
That's
Um,
just-
Whenever we square root both sides, we should always have plus or minus. Yep. Okay, so now we can subtract 10. So I should have two answers, so I could do positive 9 minus 10, which you said was negative 1. And then I have negative 9 minus 10, which is negative 19. Yeah.
That's not bad.
Yeah, this is just a start.
I thought you would give us the easy ones to do.
I'm easing into it. Okay, completing the square. So for completing the square, our goal is to get something like that, right? Some quantity to the second power. That's our goal to complete the square. So step number 1. How do I want to say this? Well, okay. We are going to get the x's on the left side. We have a constant on the right side. Okay, so these are just the steps that we're gonna do for our next example to complete the square. To complete the square, we need to create a perfect square trinomial. So step number 2, we're going to create a perfect square trinomial. By finding, and I'm going to call it the C value. Okay, so when I mean C, on the left side, we're going to have like some ax squared plus bx, and then we're going to be trying to find this C. Okay, so we won't have anything over there to represent C. We're going to create this number. So to create the C value, C is actually B divided by 2 to the second power. Okay, so we'll have some B value that's with the x. We'll take that coefficient, divide by 2, square it, and that's our C. Step number 3, we're going to factor the perfect square trinomial. And then we're going to solve by square rooting. Okay. I mean, once you get to like step 3 and 4, we've done it before. Step 1 and 2 are new parts. The key to this whole thing is remembering how to find this. Okay. So you have to remember, divide by 2, square it. And this whole setup is just kind of interesting. So basically, we use complete the square when it's not factorable. Okay, so some polynomials we know we cannot factor, so here's a method that we can do if it's not factorable. We'll learn the method when it's not factorable as well. Please continue excitement level for people. Very good, Gracie.
0 would probably.
I don't think so. Well, not today, anyways. This is only part A, so we're just completing the square. Then come back Monday. Woo!
He says I'm coming back Monday.
It's gonna be gone.
Yep. We will bring you back.
Why?
I was the one who's doing a project called Barbie Bungee. So we're bungee jumping Barbie.
What's the mathematical concept about that?
They were collecting data to write the equation of the line of Barbie bungee
Oh,
jumping.
okay, I must ask. Does college algebra only have 2 Questions?
Yes, we did.
I think it's super hard. That's fine.
What was the question?
I'm pretty sure it was like A through like H. So it was like
Oh.
8 parts to each question.
Yeah, can I say it? Well, I feel like it'd be
Yeah, it's called algebra.
I don't know, I kind of like algebra more. Or no, I can't.
Okay, so let's do this one. Find the value of C that makes this guy a perfect square trinomial. Okay, does anybody remember how to find C value? And then it's squared? Okay, so in my quadratic, what is my B value? 26, because that's the number in front of the x value. I can even put in negative 26, but we're squaring it, so it's kind of like squaring out. You know what, in a sense, words today. But follow order of operations, so we want to divide inside of parentheses first. Negative 13, and then the second power is 9. Close. Okay, so our perfect square trinomial is x squared minus 26x plus 169. Beautiful. So that's the first part. And then they say write it as a square of a binomial. So basically they want us to factor this perfect square trinomial. So how does this thing factor?
Wait, you don't just end that?
No, because we're doing the second part of the question now. Yeah.
What was the second part?
Write the expression as a square of a binomial. So you want two terms inside parentheses to the second power, square of a binomial.
You want to get rid of x.
Okay.
Which means you have to square root the 26 and you have to square the whole.
Is it 169?
Well, should we just square roots the first and last term? Yes. What's the square root of 169?
13.
13, right? We just squared 13 to get 169. Now we're going the opposite way. Is this going to be x plus 13 or x minus 13?
It's minus.
Both.
Yeah, it should be minus because it was negative 26. Okay, so this is the second part of the question. Okay, so this is still easing you into completing the square. We haven't even done completing the square yet. The process.
Are you going to do the process?
Yes, we are. I'm sure the next one is doing the whole process here. You betcha.
Oh.
Okay, so we have this lovely quadratic. We want to solve by completing the square. If I saw this without anybody telling me and they just said solve, first thing that we should always try and do is factor. But we can't factor this because our C value is 1 at the moment, and the B value is negative 10, so there's no numbers that multiply to 1 that is negative 10, right? The only products of 1 is 1, 1. There's no way that's going to create negative 10. So this is not factorable. So we have to do a different method to actually solve this quadratic and find the x values. Okay? So, to start, step number 1 for completing the square was getting everything with an x on the left side, everything else on the right side. So these parts are the x values that are going to stay on the left side. That means negative 1 has to shift over to the right side. And how do I move 1 for? Subtract it. Okay, and I'm going to set this up in a specific way. I'm going to leave a gap on the left side. So then I still have negative on the right side. I'm going to leave a gap as well. Okay, so this space I left so that way I can find the C value that's going to create the perfect square triangle on the left side.
So you're going to make me.
What? So does anybody remember how to find the C? Yeah. It's that b over 2 squared, b value is negative 10, b over 2 squared. Perfect. Okay. So then this simplifies to d. And negative 5 squared is 25. Okay, so this number 25, that's the number that's going to the blanks. So it's plus 25 on the left side, plus 25 on the right side. Now I blanks on both sides because if I add a value on the right side, I have to add it to the left side, right? I can't just do one side because then my equation's unbalanced. Okay. So we're like completing the square right now. So on the left side, I can factor this perfect square trinomial that I just created. So how does this thing factor? Should be minus because it's negative 10. Should be x minus 5 squared. We square root the first term of x, square root 25, which is 5. It's minus because of the minus 10 part. And then on the right side, we have negative 1 plus 25, which is 24. Yeah. Okay, so this whole process was doing completing the square. So now we can square root both sides, which we've done in past sections. Okay, so we haven't gotten x by itself yet. So square root all this. Left side, I just have x minus 5. What do I have on the right side? And I don't want a decimal in the simplified radical. Well, definitely have a plus or minus. Square root of 24 should be able to simplify. Does anybody know a perfect square that divides into 24 evenly? Yeah. 4 goes into 24. 4 is perfect square. So I can write it as 4 times 6. So this is our product property, simplifying radicals. 4 times 6 is 24. So then I know the square root of 4 is 2. So then that can be replaced with a 2, and I still have the square root of 6 that can't be simplified. Now we're almost done. X is almost by itself. Almost solved for. What should I do last? Add 5 to both sides. And then 5 doesn't have a like term on the right side because that's 2. The 2 is attached to the square root of 6. Which is 5 plus 4 minus 2 square root of 6. Answer found. Bam! Completed the square. Check. Solved it. Check.
Well, I haven't used this in every game.
Solving clear brackets. Why wait now?
I have 17 same equation.
Okay, I'm gonna actually modify this problem. Do I want to? Yes, I want to.
This is why I'm going to college.
You should go to college.
No.
I'm just gonna change it to 150
I took it to New York. Yeah,
to like,
No.
if I'm thinking about that correctly. Okay, last but not least, here we go. What should we do first? We're not set up to factor yet. What should I on the left side? What should I on the right side? We will, but not yet. Yeah. So first step was XLIs on the left side, constants on the right side.
Take it out or subtract your
Yeah. Move that over. So I have x squared minus 36x. Technically, I would write that blank to fill in my c value, and negative 152 with my blank. So Gracie noticed this was different than the other problem because I have that 3 for my a value. So she's right, I want to divide this 3 out, but I'm technically going to be like factoring it out of 3 and 36. Right, you can't take it out of 152. That's why I changed it, because you will have a problem like this in homework where you can't take it out of all 3 terms. If you can, you absolutely should, because that makes it way easier. Just divide it out. Okay, so taking a 3 out, or like factoring a 3 out, so then I have x squared left over. And what's my next term? If I take a 3 out of 36, what's the
Oh.
Oh my god. 12?
well, we're dividing it out. Okay. I'm still going to keep my blank along with the right side with my space. Okay. So now inside my parentheses, I still want to figure out the perfect square trinomial. So I need to figure out what goes in the blank. My c value.
I forgot what it was. Oh, you divide your 36 or 12
Divide the 12, because that's my new b value.
by 2, 6, 36.
Okay. So that goes in the blank. This one we have to be careful though, because 36 is in the blank in parentheses. This whole parentheses is being multiplied by 3. Right? So I can't just write 36 in the blank on the right side, because this number is actually bigger on the left side than what we realize. So if you have it in parentheses, you should do 3 times 36 to figure out what goes in the blank on the right side. So what is 3 times 36?
One way.
108. Okay. So then it's negative 152 plus 108, which is
That's negative. Oh.
mhm. And I did 42. Okay. Beautiful. The left side. Oh, I made this one way harder than I needed it to be. Okay, so this has to be factoring the left side. How does x squared minus 12x plus 36 factor?
Wait, say that again.
How does x squared minus 12x plus 36 factor? What's inside my
So it must be x minus 2.
Okay, so now it's in like this whole quantity squared. So I'm gonna get that quantity by itself. So we should move the 3 over and have to do that. Divide it. Don't ever try and distribute these. So yeah, the sad part about this is when I change the problem now, I messed everything up. Because negative 44 divided by 3 does not divide
Oh, so you want to make that 6 too?
Actually, let me. I might change it. If it works. Nope, it doesn't. Never mind. It's just gonna stay complicated. Cross your fingers, you won't get a problem like this on. I have no idea. So, yeah. This is just gonna say, as an improper fraction, it'd be nice if you could divide. Hopefully you don't get one like this on homework assignments. I'll have to check. I might change it if you do.
Can you just put 14 in here?
You can, but then it makes it complicated when we're gonna try and simplify this. So yeah, we're gonna square root both sides. That's our next step. So yeah, this is where it's all just complicated. So I have plus or minus the square root of negative 44 thirds. And we need to simplify this radical, which is a peach. So it's like we're bringing everything that we know about square roots together in one lovely fraction here. So technically I can't square root negative numbers. So how do I pull that negative out of the square root?
Yeah, but then you're.
We learned about something that represented the negative, or the square root of negative 1. What?
You just pull out.
I like to, and then we have to replace it with something. What did we do yesterday? Oh wait.
Yeah. You're absolutely right.
Kind of. What's the overarching thing that we did yesterday and the day before that? Like the overarching thing, the whole thing. What do we do the last 2 days? Or what's the new thing that we learned about? Imaginary numbers. Okay. So the square root of negative 1, we can take out the negative and replace it with the imaginary number. Okay. So this right side becomes plus or minus I square root of positive 44 over 3. We still have x minus 6. Okay. We still need to simplify this lovely radical sign. So we have what is called the quotient property. So I can split the radical to both the numerator and denominator. And I need to simplify this. So problem number 1, I have a radical in the denominator, which is no good. Problem number 2, I can simplify the square root of 44. So what do I want to do first? Work with the 3 or the 44? Okay. So what perfect square divides into 44?
10, 4, or 11, 4.
11 and 4. So then I have square root of 4, square root of 11, over square root of 3. Square root of 4 is 2. Okay. So simplify the square root of 44, that part's done. Now I need to do that square root of 3. So, what? Multiply by 3? Is that what you said?
I said 1.
Oh. Yeah, so I need to move the radical from the denominator up to the numerator. So to do that, we multiply by the square root of 3 to the bottom and the top. This is called rationalizing the denominator. We did that like last week sometime. See all of these things coming together in one beautiful problem. Aren't you glad I changed it for you? Oh. Okay. So what do I have in the numerator? The square root of what?
11 times 3.
Which is
33.
33. Yeah, 11 and 3 are both underneath the square root. We can multiply them together. What will I have in the denominator?
Or something.
What?
Or something.
Technically, it's just 3, because you would multiply those two numbers, because they're both under your radical, and you get the square root of 9. But then the square root of 9 is actually just 3. Okay. So then we're on to the last step. Finally, we have the radical simplified. Add 6. Woo! So 6 plus or minus I times 2 square root of 33 over 3. Answer, finally found it. Yeah.
Huh.
So after completing the square, hopefully you start to appreciate how factoring is way simpler than completing the square. Completing the square is complicated. Factoring is a lot simpler. Less steps. Bye.
Good thing we're direct vegetable, so
Yeah.
There's a lot of things. That was a good one. Yep.
What math classes did you take in college?
Me?
Yes.
A lot.
Okay.
Yeah, all of them.